So today we're going to start with Coulomb's law in electrostatics. What is Coulomb's law? It is actually a law which covers the magnitude of force between two charges. Suppose we have two charges q1 and q2, which is separated by a distance r from each other. Then there is existing a force, electrostatic force between these two charges, and the magnitude of that force is given by Coulomb's law. The magnitude can be established from the law of gravitation, where we know that if there are two masses m1 and m2, then the gravitational force between those two masses is g m1 m2 by r square. Similarly here, according to Coulomb, the electrostatic force existing between two charges q1 and q2 is directly proportional to the product of the charges and is inversely proportional to the square of the distance between them, and hence we get a formula for the Coulomb's force as F equals to K is a constant q1 q2 upon r square. This formula is known as Coulomb's force, and if you write this in statement, it becomes Coulomb's law. So if we state Coulomb's law, then it will be like this: the force of interaction, because between two charges the force may be of attraction or repulsion. That's why this force is known as force of interaction between two charges is directly proportional to the product of their charges q1 q2 and inversely proportional to the square of the distance between them. And in order to establish a relationship for force, we have to multiply a constant k, where k is called Coulomb's constant and is having a value of 9 into 10 to the power 9, whose unit is Newton meter square per Coulomb square. This k can also be written as 1 upon 4 pi epsilon naught. 4 pi epsilon naught, where I am going to tell what is epsilon naught. Epsilon naught, we can write k as 1 by 4 pi epsilon naught. This epsilon naught is a very important quantity and is called as permittivity in free space.